There are so many misleading and mistaken explanations of the twin paradox on YouTube, I have decided to publish critiques of some of the more popular versions. There are brilliant scientists getting it wrong. Their mistakes often stem from a scandalously persistent error in the original spacetime diagram published by Hermann Minkowski in 1908. The diagram's essential flaw is that it projects the clock of the observer onto rays of light. But according to relativity, every body has its own clock speed, and the clock speed of light is zero. So instead of a diagonal, light should be displayed as a horizontal. Almost everything about the diagram is distorted as a result of this pre-relativistic error. In the second link listed below, I discuss numerous insights about relativity and the strange features of light that follow from a relativistically correct diagram. A spacetime diagram is supposed to represent relativistic relationships as expressed by the Lorentz transformation. The equation is often written in convoluted ways, but put simply, and isn't that how equations are supposed to be put? It can be expressed like this. T prime is a time span of a body in relative motion, compared to t, the time span of an observer taken to be at rest. Their relationship is determined by the relative velocity v and the speed of light c. The equation is usually written with v squared over c squared instead of just v squared, but by treating v as proportional to c, there is no need for that complication. There are several other standard, unhelpful complications I've omitted as well. The alternative diagram I'm offering treats bodies in relative motion as they are expressed in the mathematics of relativity. The clock speed of light is zero, not equal to that of an observer. So a body moving at 80% of the speed of light relative to an observer has a relative clock speed of 60%, and as you can see, it already transgresses the 45-degree diagonal of Minkowski's light cone. At point 8c, relative to an observer, a body moves about 53 degrees from the vertical. An important consequence of treating velocity v as proportional to c in the Lorentz transformation, particularly for the critiques that follow, is that it reveals in the alternative diagram that there is a Euclidean relationship between bodies in relative motion. The clock of a body moving at 0.8 of the speed of light will take 6 seconds relative to an observer's 10 seconds. That's a classic 3-4-5 Euclidean relationship. And no matter what the relative velocity, this means the world line of a body in relative motion, as the hypotenuse of the triangle shown here, will necessarily be equal in length to the world line of the observer, who stands in the same relationship to the right-angled sides of the triangle as a hypotenuse. This too will be an important point in what follows. For a more detailed treatment, please see the link below the screen for my presentation on special relativity. A lot of misrepresentations can be clarified with a truly relativistic diagram. For example, the seeming absurdity of two observers each measuring the clock speed of the other as being slower than their own becomes clear. With different orientations in space-time, their frames of reference can be seen to mirror each other. The alternative to the Minkowski diagram is well suited to explaining and understanding the twin paradox too. I'll be using it in reviewing some of the most popular twin videos on YouTube. 4 of the most representative videos will be discussed here and now. More critiques will follow. In Special Relativity and the Twin Paradox, physics girl Diane Cohen gets it right. She identifies the source of the non-paradox as acceleration. Her presentation is beautifully simple, probably the most accurate and the easiest to understand on YouTube. There are issues that she has purposely omitted for the sake of simplicity, and she doesn't explain a central problem. What about the time spent not accelerating when both twins are viewing the other as aging more slowly? And she doesn't try to defend against the skeptics and eccentrics. But I suspect that she is happy to leave that to others, as are viewers with just a casual interest in the subject. Dialect is a group or organization that has produced 5 very professional videos to date, critiquing the various contenders for a satisfactory explanation of the twin effect. But strangely, after the 5 videos, they have yet to come up with an explanation of their own. I'll focus here on their emphatic rejection of acceleration as the basis of the twin effect, which is the most deliberate and yet mistaken effort I've seen. They insist that acceleration is, quote, purely coordinative, meaning that like relative motion, it's a phenomenon that depends on an observer's coordinate system. They give numerous examples of how it can be difficult to tell if you are being accelerated, and they seem to believe that it is enough to show that it can be problematic to feel an acceleration to declare that it's relative. But conventional science tries to overcome problematics by constructing experiments that can isolate principles in question to establish their validity. Einstein's great gift was his ability to conceive of thought experiments that could reveal physical relationships which have never been imagined or appreciated, like the experiment that identified falling in an elevator with floating in space. Acceleration can be isolated and clarified by imagining the inside of a spaceship out beyond significant gravitational influence. If the ship is not being acted on by a force, a ball will float freely inside. If the ball is electrically in neutral, not even a magnet can confuse things by causing it to accelerate. But if the ship's rocket is switched on, the ball will immediately travel to the wall or bulkhead in the direction of the rocket engine, and it will stick there as long as the rocket is firing. Problem solved. Acceleration is real and absolute, not relative, and it can't be claimed that another spacecraft can be considered the one accelerating if its engine is idle and a ball is floating freely inside. An alternative to Minkowski's space-time diagram can reveal acceleration to be more than just a relative and local phenomenon. Acceleration is a real and absolute movement out of time into space. Unlike relative motion, it cannot be mirrored, and unlike the other explanations for the so-called twin paradox, which include coordinate change and sometimes mathematical sleights of hand, it is acceleration that can have the actual, non-relative effect of reducing motion in time and producing differences in age. The diagram here shows that given the principle of equality of world lines mentioned earlier, an accelerating body that moves out of time across space must be moving less in time than those that are in uniform motion. I believe the common refusal to credit acceleration as a source of real time dilation is a theoretical oddity that can be traced to the failure of the Minkowski diagram to adequately represent it. If acceleration involves an actual slowing of clock speed, it follows that from an accelerating perspective, the clocks of non-accelerating bodies will be ticking faster. So beyond the controlled experiment inside a spaceship, the way you can know acceleration is real is this. If you observe other clocks to be moving faster than your own, you are accelerating. Absolutely. Now, let's look at a common explanation for the twin effect that attributes it to the traveling twin having changed direction. Can it also account for differences in aging? Einstein's twin paradox, explained by Dr. Amber Stuver, is a beautifully produced and carefully reasoned video. In her version of the twin effect, traveling twin moves at a relative 86.6% of the speed of light, which reduces relative clock speed by half. The twin goes to a different star, then returns to her twin on Earth having aged less, despite her purely relative, unaccelerated travel. Probably for the sake of simplicity of presentation, there is no consideration of the accelerations that would be needed to change speed and change direction. The one twin is shown to instantaneously accelerate away, decelerate at her destination, accelerate back, and decelerate to Earth. But curiously, Stuver does state explicitly that all movement is relative, so presumably, whether it is uniform or accelerated. Here is a reasonable facsimile of Dr. Stuver's space-time diagram. Her explanation for the traveling twin, whom I'll call twin B, aging less than the stay-at-home twin, twin A, is that in order to turn around and make her return, she rotates into a different orientation, or frame of reference, or coordinate system, relative to the whole universe. This seems to be the most common explanation for the twin effect. Stuver reasons, as do others, that the change of direction can't really be relative, because we would have to say that twin B is not turned 180 degrees. It is the entire universe, except for B, that has. But this doesn't actually hold up. It may seem absurd to suggest that the traveler can be at rest while the rest of the universe is changing direction, but it's nonetheless true that there is no absolute state of rest, or frame of reference, or coordinate system. Every body in the universe has its own orientation of time to space, and every body turns alone. If you take acceleration out of consideration, that forceful wrenching out of the free-falling perpendicular of time to space, all you have is a new westerly instead of easterly. People in San Francisco are constantly moving in the opposite direction of people in Perth as the Earth freely spins, and there is no cumulative relativistic significance to the ever-changing frames of reference of Yanks and Aussies. There is another sort of problem with Dr. Stuver's presentation. Twin A's clock is represented as having elapsed 23 years when B returns, compared to B's elapse of 11.55 years. This is mistaken, and Minkowski's hyperbolic pre-relativistic geometry is to blame for its inability to provide an accurate visualization and interpretation of space-time. This alternative diagram can make the error clear. As with Stuver's diagram, twin B, moving 10 light years at 86.6% of the speed of light, according to A, will take 11.55 years to reach your destination with a clock speed of 5.77 years. Incidentally, another example of the utility of the alternative diagram can be seen in how B's orientation in space-time, being rotated relative to A's, has a length contraction to the distant star of 5 years. This provides a graphic answer to the claim of the absurdity of relativistic length contraction that has kept many theorists busy trying to refute relativity. As the diagram shows, it is a different orientation in space-time that produces different relative distances in both space and time. In representing the traveling twins' return trip, the alternative diagram takes a different sort of turn. B's return shows perfect symmetry in the to and fro, and is home at exactly the same time as on A's clock. With uniform motion as opposed to acceleration, there is no difference in aging between the twins. It's worth noting, Minkowski's diagram cannot suggest this surprising result. And actually, there's a problem here with my alternative diagram too. Note that the world lines of twin B add up to be twice the length of A's single world line. In both diagrams, Stuver's and mine, when the traveling twin turns back toward the stay-at-home, A is treated as if at absolute rest, and B as absolutely in motion. The problem here is that given the turnaround, the twins' relationship no longer mirror each other accurately, because all the while they have been, in effect, mutually moving and at rest. I'll return to that. The coordinate change explanation for the twin effect is often represented by a thought experiment with regular light flashes from each twin. I've taken the liberty of showing Dr. Stuver's illustrations of how an asymmetry would occur if each twin would send a flash to the other every year of the journey. It's an excellent example of how Minkowski's original depiction of relativity has been a hindrance to the understanding of relativity. Note that the light rays are depicted as traveling at diagonals, as if they were moving in time, by an illicit projection of the stay-at-home twins' clock instead of the clocks of the light rays themselves. The only way to properly represent the twins' uniform relationship is to treat them both as at rest and in motion, by taking a transcendent, actually transphysical perspective, as in this diagram, where they each share half of the relative motion between them. It's the only way to avoid treating them as either absolutely in motion or absolutely at rest. If there is unaccelerated movement between two people or two objects, and one could somehow turn around and return without accelerating, an equal share of the overall motion actually belongs to each of them. And that is why with relative motion, excluding the effects of accelerations, the twins would reunite at the same age. The time-lapse of any portion of a journey that involves uniform relative motion will resolve itself at the reunion. So the ultimate rationale of frame reversal interpretations of the twin effect rests on the idea that the reversal of direction produces an asymmetry between the twins' coordinate systems. Here is an alternative representation of Struve's regular exchange of light flashes shown earlier, in contrast to what Struve and other frame reversal advocates use to support a supposed asymmetry between the twins' clocks. There is a perfect symmetry here, which is as it should be, because there is only relative motion between the twins. The dashed blue lines are not world lines. They indicate the transactions of the light rays between the space-time locations of their emissions and receptions. An unavoidable problem with any static space-time diagram is that it suggests that world lines travel up and away from their space axes. But of course, bodies moving in time always remain in space, and their space axes actually travel along with them. This may be the main reason for the continued confusion about the motion of light. Although moving parallel with space, and with world lines equal in length, whether moving in time or not, light rays seem to trace 45-degree angles when the space axis is left in place, while the diagram illustrates movement forward or upward in time. If the diagram were animated, light rays traveling between the twins would move equally upward and sideways, actually parallel to the space axis, as the twins move upward in time at the same speed as the light rays move sideways in space. Frame reference theories of the twin paradox are, like the Minkowski diagram they are based upon, imperfect and misleading representations of relativity, and motivated by a denial of acceleration, they have to try to pull a discrepancy of clock speeds from purely relative motion in order to account for the twin effect. Now for consideration of some fairly irresponsible trickery. A popular non-explanation of the twin effect is that of Don Lincoln at Fermilab, who uses quote, unquote, real math and real logic kind of like magic tricks. In the beginnings of his videos, he says flatly that acceleration is not a factor in the twin paradox. Then oddly, truly oddly, his version of the paradox doesn't even have the traveling twin return to the origin. As the one twin sails away forever, another traveler, coming in the opposite direction, somehow magically carries some sort of essence of the twin's relative motion just by passing him by. But if there was no receding traveling twin, the approach of the third person would be no different, carrying the same relative time dilation either way. But somehow, the stay-at-home twin has, by Lincoln's fabrication, two reference frames to compare, and that makes one twin younger? Really? No, there's really nothing to say about this supposed explanation, but are you serious? Okay, that's all my critiques for now. I'll be back again with more in an effort to give the effect of acceleration its due. Meanwhile, if you haven't done so already, please have a look at my own explanation of the twin paradox. I should say the twin effect, reference below. Thanks for watching and listening.